It's science time. Let's explore. Let's enjoy. Good afternoon. It's science time. Your daily life, your daily learning. I am Mark Casio, your teacher. It is another wonderful day, isn't it? Yes, it is. Because today you're going to have another interesting topic. Before we begin, I want you to have your module copy for your reference, a notebook, and a pen for writing as we go along with your lesson. And most importantly, I want you to listen carefully, understand, and participate in your lesson. All right, let's get started. Let's begin with a short pretest. I will give you the question. You're going to choose the correct answer. Here it is. First question. The correct answer is D, soap. It's easy, right? How about this? The correct answer is C, base. And for the last question, the correct answer is A, acid. Did you get it right? Don't worry, you'll know why in this lesson. Before we talk about acids and bases, let's have a short review on elements and compounds. Let's start with a question. Which of the following is an element? A. Paper. B. Water. C. Salt. D. Gold. The correct answer is D. Gold. Let's find out why.
Element is the simplest form of a pure substance. The keyword is simplest. What does this mean? This means that elements can no longer be broken down into a simpler form by any means. For example, gold. We cannot break down or do anything to change it, or simply we cannot make it become an aluminum or oxygen or any other form since it retains its own properties. What are the other examples of elements? All the elements on Earth are listed on the periodic table. There are 118 elements. Most are naturally made, like the copper, gold, oxygen, hydrogen, and many more, while others are man-made in the laboratory. Most are solid, and the others are liquid or gas. This is the periodic table of the elements. You find here the complete list of all the elements, written with their own symbols. Just like, for example, the element hydrogen is represented by its symbol H. It is interesting to learn more about elements using this periodic table. But anyway, you will have this in your grade 8 science. Now, we'll have a short review on compound. Compounds are made up of elements. They are also pure substance. Compounds are formed from the combination of two or more different elements by a chemical reaction. But compounds can still be broken down or separated into simpler form, unlike the elements. The illustration will show us how. For example, this AB, this compound AB, is shown by an arrow that it is from the combination of two different elements, elements A and B. For example, the water, also known as H2O. Water is a liquid compound. It is formed from the combination of two different elements, namely the hydrogen and oxygen. Both are gases. Hydrogen is a flammable gas, while oxygen is what we breathe. But when these two elements are chemically combined, they form a new substance, which is the water. Isn't that amazing? It looks like a magic. Gas and another gas combined, and they produced a liquid compound, which is the water. It's look like some magic, but that is science. However, water can still be separated or brought back into the previous components as hydrogen and oxygen gas through a chemical process called electrolysis. This is how compounds are. They can be made and be broken down into their simpler forms by chemical means, as illustrated above. AB, for example, the compound AB is shown by an arrow that it is made from the combination of two different elements, say element A and element B. Or we can also explain it this way. Compound AB can still be broken down into two different elements, such as element A and element B. That means that compounds can be made from the chemical combinations of elements, two or more elements, but they can still be broken down into simpler forms. What are the examples of compounds? The common examples are the salt, the table salt, sugar, water, carbon dioxide, and many more. In fact, there could be limitless examples of compounds that can be made. Just imagine that there are 118 elements that can be combined to make a new substance called compounds. However, some elements are not chemically reactive to others, so they can't be chemically combined. Thus, they cannot form a new substance or compounds. Just like the gold and iron, if we mix them, they are still gold and iron. Their combination does not produce a new substance, a compound which is different from each of them. These are your learning objectives. Please take note of them. Let us read them together. First objective: compare and contrast acids and bases by their characteristics or properties. Second, identify uses of some common acids and bases. Third and the last objective, be aware of the harmful effects of acids and bases. Now, let's talk about and learn acids and bases. Why do we need to learn about acids and bases? Because they are a part of our daily life. We eat, drink, and use them every day. Just look at the picture there. People are looking for the products they may need in their daily lives. And those products contain either an acid or a base. What are acids and bases? Basically, they are also examples of compounds. It means they are made up of two or more different elements. Let's start with defining acids. Acids are also compounds. They are usually in a liquid form. which generally contains the element hydrogen that reacts or combines with other elements to form a type of acid or other substance. Just like the example there, the element hydrogen is there with the letter H, and it combines with another element, which is the Cl or chlorine. That combination produces an acid. Let's find out what acid is that. There we go. That acid is the hydrochloric acid. It is one common example of an acid, or we know it as muriatic acid. We use this in cleaning, disinfecting, and many more processes. This acid is formed from the chemical combination of two elements, which are hydrogen and chlorine. The H there and the Cl there is the chlorine. In addition, hydrochloric acid is a strong acid. It is present in our stomach that helps digest the foods we eat. However, this can also cause trouble in our stomach like ulcer, hyperacidity, if we do not observe regular eating habits or if we do not eat the right foods. So, uh, the picture there shows us the stomach, our stomach, which is naturally containing an acid, specifically the hydrochloric acid, that stays in our stomach because it helps digest our food. Without that, our food will not be digested as uh, properly as it is needed. Hydrochloric acid can also burn or destroy your skin or our skin or even other materials if too much amount is used. It can also explode if mishandled and corrode or eat away metals. So the safe proper storage containers of acids should be made of durable plastic materials rather than metal that is reactive to acid or glass container that can easily break. So if you see the safety sign there, your hand being dropped by a liquid there, that means it is corrosive. Be careful with it. So what are the other examples of common acids? These are some common examples of acids. Okay, first, we have acetic acid. Acetic acid, this is used in making vinegars. That's why vinegar tastes sour because it is basically made from acetic acid. Citric acid, this is found in fruits as vitamin C source. Carbonic acid, making soft drinks. Ascorbic acid, also the same with citric acid. This is used in making vitamin C. More examples of acids. We have sulfuric acid, nitric acid, boric acid, lactic acid on milk, formic acid on bee sting. There you see them in the picture. So, how can we know or determine if a substance or mixture is acidic? By their general characteristics. So, we have the general characteristics of acids here that will help you determine or identify acidic substances or mixture. So first, acids taste sour. You see it in the picture, a child with a sour face upon eating a fruit. So it's easy. If it tastes sour, it is acidic or it has acid in it. But take note, don't taste any product or material if it is not safe or not edible. Second, acids turns blue litmus paper to red. So, one way of identifying or determining acidic substances is by the use of a litmus paper. A litmus paper is a kind of paper, you see it in the picture there, being held by the hand and being immersed into the liquid. If that litmus paper turns into red, it means it is acidic or the sample